I'm very excited about an idea that uses these things called thermosiphons. And a thermosiphon is nothing more than a heat pump.
I see.
But it's a passive heat pump.
Uh-huh.
So it works like the heat pump in your house, or there's a heat pipe in your computer.
Mm-hmm.
We use these things all the time. The nice thing about the thermosiphon is at least in our preliminary work modeling these things, it appears as though the difference in temperature between the bed and the surface of the ice is enough to drive the heat pump itself. So we're taking advantage of the energy that is already in the system to drive this. And so the way it would work is you would basically drill a hole from the surface to the bed, which is something that we do.
Yes.
We have the technology to do this. And you drop in a vertical pipe.
Okay.
To, pretty close to the bed. That pipe will be filled with pressurized CO2.
Okay.
CO2 seems to be the best working fluid that we have. And it's pressurized to somewhere around, 400 to 500 PSI. And the reason that you do that, of course, is that at those pressures and under the temperature conditions that we see in the ice, the CO2 is going to be a liquid at the base of the pipe.
Okay.
And then it absorbs heat.
Okay.
And it melts.
Because
again, the bed is the bed is the warmest part. It evaporates.
Evaporates, that's the word,
Yeah, and so and then the vapor rises to the surface.
Yes.
Where it recondenses.
I see.
Releases its latent heat to the atmosphere.
Yes.
And the amount of heat that we're talking about is trivial compared to what the atmosphere can handle. So, when we're talking like milliwatts per square meter of heating, right? It's very small, but it's enough to manipulate the glacier. And so, once it recondenses at the surface, of course, it just rains back down to the bottom, and then this process continues.